how are you all? I hope you all good. Today we are going to discuss in this chapter 3 matrix, example problems, exercise number 3.1 and multiplication of matrices. Before going to our class, as usual, let's close our eyes, let's have a word of prayer. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Alright, let's move on to the multiplication of matrices first. Then we'll go for example problems. Then we'll start exercise number 3.1. Okay. So I hope so you are doing your homeworks and some are commenting on YouTube. That is also good. And still, if you have doubt, you can send me a message so that I can help you all. Alright, let's move on to the multiplication of matrices. What is the rule behind that? Okay, right. We are going to discuss multiplication of matrices. If I take two matrices A and B, then what is condition to multiply two matrices? So condition is this: the first matrix number of columns should be equal to the second matrix number of rows. If it is satisfies this condition, then only we can say that multiplication of matrices is possible. Otherwise, it is not at all possible. For example, I take A as m by n and B should be n by p. Means, so it is first matrix columns, number of columns should be equal to the second matrix number of rows. So then only it is possible to find that multiplication of matrices. So if it is, for example, A m by n, B is like p by q is there, then you check here, it is n, it is p. So means number of columns is not equal to the number of rows of second matrix. Therefore, we cannot find product of AB. Or we can say that we cannot multiply two matrices. So this is about multiplication of matrices. And what is general form of a matrix? So you just observe so that you can understand what is general form of a matrix. So here I am writing a general matrix, whichever it is. So in your examination, maybe they may give capital A is equal to Aij 3 by 3 matrix. Then what to do? How to write this? So then that A is equal to 3 by 3 means how many rows and how many columns? 3 rows and 3 columns. So here I indicates, here you can observe, this I indicates rows and J indicates columns. Okay, then. So here if I need to write that, so for example, if I want to write how many required here for me, totally 3 by 3 means 3 3s are 9, 9 elements are required. So how I'll write? So A11, first row, first column, first row, second column, first row, third column, right? Same method here, second row, first column, and then here second row, second column, second row, third column. Same method, A, third row, first column, and then this is again third row, second column, third row, third column. So in this way you will write the general matrix. So this is for 3 by 3. If they given here 2 by 2, so here A is equal to Aij 2 by 2. Then how to write 2 by 2? Again same method, A is equal to 2 2s are 4 number of elements you will get. So A11, A12. So 2 columns completed, 1 row completed, then second row. So A21, A22. So you observe now it is 2 by 2 matrix. So you can write, if they given Aij, you have to in this way, first one always, that I indicates rows, J indicates columns. This is about the multiplication condition for the matrices and general matrix. Now let's move on to the example so that you can understand clearly. Alright, let's move on to the examples. First problem. The order of A is 3 by 5. Order of A is 3 by 5. And R is a row matrix of A. R is which matrix? Row matrix of A, means it is, we can say that inside of A, one row matrix we need to find. Then write the order of R. It is very simple. So the solution it is, so you already know that how many rows are there? 3 rows. And how many columns are there? 5 columns. That indicates that each row consisting of how many elements should be 5. If you want to write some other manner, so if you want to write the first one, I'll write only the first one, that row matrix order I'll write. Before writing that, first what were they given? So since order of A is 3 by 5, this is the given. So therefore, so I can write therefore order of R is, that row matrix is 1 by 5. How? I'll write here so that you can understand. So here 3 rows and each row have 5 columns. So now first one, what should be? 1 1, 1 2, 1 3, 1 4, 1 5. So each row consisting how many elements? 5 elements because of 5 rows. Okay, so that's the reason here you written as 1 by 5. Okay, this is general matrix of that R. Clear? So this is about order of R, and we written order of R, and we written even matrices also. That is about your problem number 1. And now find a matrix of order 2 by 3. A is equal to Aij, whose elements are Aij is equal to 2i plus j and Aij is equal to I square minus j square. It is again very simple one. So let me solve that. So solution. So here 2 by 3 they said. So 2 rows and 3 columns. Let me write first general form. So that is A is equal to, so 2 by 3 means A1. So first row, how many columns here? 3 columns. So first row, first column, first row, second column, first row, third column. Same method, 2 rows are there. So that A21, A22, A23. This is your general form, that is 2 by 3. So now first one I will take. What is that first one? Aij is equal to 2i plus j. So now A11, A12, A13, A21, A22, A23. These values find. Just substitute it. Simple. So now A11. I also 1, J also 1. 2 into 1 plus 1. So 3 you will get. Same method A12. So 2 into 1 plus 2. So that is 4. A13. So that 2 into 1 plus 3. So that becomes as 5. Same method now. A21. So that 2 into 2 plus 1. 4 plus 1 is nothing but 5. And same method A22. So that is again 2 into 2 plus 2. 4 plus 2 is nothing but 6. So then A23. That is again 2 into 2 plus 3. That is nothing but 2 to 4, 4 plus 3. 4 plus 3, 7. So now you got all the elements. Just substitute it. I'll rub this part so that it becomes very easy for you all. Okay. So I'll rub and I'll write for you all this again back. Okay. Here I'll complete that part. So your required matrix now. You can write here required. So we can write required matrix. So let me write. So required matrix is equal to, so A11. What is A11 here? 3. Next A12. 12 is nothing but 4. And A13 is nothing but 5. Next A21 is nothing but again 5, and then 6, then 7. So this is about your required matrix with 2 by 3 order. So that is about your first Roman. So then let's move on to the second one. In this second is what is here? Aij is equal to I square minus j square. Again same A11, A12, A13, A21, A22, A23. That's it. So now again here equal to very simple one. I square minus j square. 1 square minus 1 square 0. 1 square minus 2 square. 1 square is 1. 2 square is nothing but 4. 1 minus 4 is nothing but minus 3. And same method next. A13. 1 square minus 3 square. 9 minus 1 is nothing but minus 8. And next one 2 square minus 1 square. And then 2 square minus 2 square. 2 square minus 3 square. So what you are going to get this all. So now again same method here also. 2 square 4, 4 minus 1 3 you will get. 2 square minus 2 square 0. 4 minus 9. 4 minus 9 is nothing but 5. So now just write here your required matrix. I'll write here. You write that down. I'm writing inside. Okay. Required matrix is equal to 0, 3 minus 3 minus 8, 3, 0, 5. So this is about your required matrix with 2 by 3 order. So this is about your problem number 2 of example. Now let's move on to the problem number 3. Alright, let's move on to the problem number 3. For what values of x, y, z matrices A and B are equal? So you already know that if A and B are equal, that corresponding values should be equal. So first write given A is equal to B, and what is your A here? 2, 0, x plus 3, y minus 4, 4, 6, that is equal to what is your B? 2, 0, 6 minus 2, 4, 2, z. So this is the given, and what values these both are equal means just comparing corresponding elements and just make that as equal, then you will get your answer easily. So the first one here it is x plus 3 compared with the 6. So comparing corresponding elements, x plus 3 is equal to 6, x is equal to 6, here plus 3, go to that side, minus 3, so x is equal to 3. Next, y value I want. So y value again this compare these both. So what you are going to get, y minus 4 is equal to minus 2. Minus 4, go to that side, plus 4. Y is equal to 4 minus 2. That is nothing but 2. Y value also you find. And now you need to find what z value you have to find. And z value also very easy. Compare these two now. So then 6 is equal to 2z. So 6 is equal to 2z, 2 here multiplying, go to that side division, so directly cancelling, 2 3s are 6, so z is equal to 3. So at last your answer is x is equal to 3, y is equal to 2 and z is equal to 3. So that is about your problem number 3. So I hope you all understood. It is very simple, just you need to compare and find your answer. Same method now your fourth problem also. Here directly they given equal, then find the values of x, y, a and b. So directly I am writing here itself solution, but you need to write first this and then you need to write comparing corresponding elements. But I am writing here directly comparing corresponding elements. Okay. So now first I will keep these two. And then these two, when I solve, I will get x and y values. And again a minus b, first one, and again 2a minus b, and these both are compared, we will get again a and b values. Let me take that equations. 2x plus y is equal to 3, x minus 2y is equal to, here it is 4. Equation 1, equation 2. What I will do here it is, I want easy calculation. So for that purpose, let me solve this itself. Here multiply this with the 2. So second one with the 2. Then what you get? 2 2s are 2 into x, 2x minus 2 2s are 4y. That is equal to 4s are 8. So I multiplied this equation 2 with the 2. After that, you take your equation number 1 and as it is, right, 2x plus y is equal to 3. Just subtract it. Here it is equation 2 minus equation 1. This I was doing, okay. So then minus symbol, here also minus, here also minus. These both get cancelled. Now minus 4y minus y is nothing but minus 5y. That is equal to 8 minus 3 is nothing but 5. Then 5 and 5 get cancelled, your minus go to that side. So this plus 1 comes to your minus 1, minus y go to that side plus y. So y is equal to, you get as minus 1. So you got y is equal to minus 1. Just substitute that y is equal to minus 1 in any equation so that you get your answer. So I'll substitute this 3, I'll give 3 in 2, I'll substitute. What I'll get? So x minus 2 into y is nothing but minus 1, that is equal to 4. Minus into minus plus. So x plus 2 is equal to 4. Plus 4 plus 2 go to that side, minus 2. X is equal to 4 minus 2, that is nothing but 2. So at last you got x is equal to 2 and y is equal to minus 1. So that is about your problem number 4, x and y values. It is about x and y value. This is about your x and y values. X is equal to 2 you got, y is equal to minus 1 you got. Now you are going for a and b values. So first a minus b is equal to 4. Second one, 2a plus b is equal to minus 1. So now what I'll do is just add both. So let me give this equation number 4 and equation number 5. 4 plus 5 implies, this both add. Minus b plus b get cancelled. Then 2a plus a is nothing but 3a. That is equal to 4 minus 1 is nothing but 3. So that 3 get cancelled. A is equal to what you got? 1. So a is equal to 1. Substitute in equation number 4. So this 5. Alright, 5 in 4. Then what do you get? So 1 minus b is equal to 4. Now 1 minus, here plus 4 comes to your minus 4. Minus b go to that side plus b. So this implies b is equal to minus 3. So now you got a is equal to 1, b is equal to minus 3, and same method, x is equal to 2, y is equal to minus 1. At last we'll write therefore x is equal to 2, y is equal to minus 1, and a is equal to 1, b is equal to minus 3. This is about your answer for your problem number 4. So that is about your third and fourth problem, and hence we completed our example problems. Now we are going to solve our other exercise number 3.1 we are going to solve. That's about examples. Let's move on to the exercise number 3.1. Alright, now we are going to discuss exercise number 3.1. So this is about your exercise number 3.1. First question, second question, third question and fourth question we are going to discuss now. So first question, if the matrix A is equal to A is a 2 by 4, then find the number of elements of A. Very simple. If you want to find number of elements, just multiply the order. So that is 2 by 4. 2 4s are how much? 8. So number of elements are 8. If 3 by 3 means 3 3s are 9. So directly 9. So next one, find out the unit matrix of the order 4 by 4. So here it is 4 by 4 they said, and you already know that unit matrix means the principal diagonal element should be 1 except that remaining all should be the 0. So that is also solution I am writing here. I will denote that unit matrix with I 4 by 4 is equal to, so 4 columns and 4 rows, right? So in diagonally you can keep 4 ones, 1, 1, 1, 1, right? So 4 ones we kept and remaining all zeros, 1, 2, 3, 1, 2. Next 0, 0, 0, 0, 0, 0. Clear? This is again 4 by 4 matrix. So here main important unit matrix means this principal diagonal one should be 1. If 1 is not there, it is not at all unit matrix. So let's move on to the problem number 3 so that you can understand that problem number 3 also. So now here problem number 3 is here. Just equal the already given and find the value of A this side. So first compare corresponding elements. So then you can understand. So when you write comparing corresponding elements, first find the K value, then you are able to find A value. So K minus 6 is equal to, this is our solution. So you need to write again first these two matrices, then you need to write comparing corresponding elements, okay? So K minus 6 is equal to minus 4. Minus 6 go to that side, plus 6. So K is equal to 6 minus 4. K is equal to what you get? 2. So now here what is there? K plus 4. When you compare corresponding, K plus 4 is equal to, the first element is A. So now here K is nothing but what do you know? 2. So 2 plus 4 is equal to A. A is equal to 6. Therefore A is equal to 6. We just want only this value, that is A is equal to 6. That is about your problem number 3. So now we are going to the problem number 4, and this is again just like your example number 4. Okay. So this also, okay, this fourth one again very easiest one. It is not very difficult. How it is very easy? Just you can observe. Find the possible orders of matrices with 6 elements. 6 elements means if you don't know this, you just remember 6 in which tables you get. That is the simple one to find the order. Possible orders. I can write here possible order of matrix with 6 elements. So first which table? First one table, 1 6 are 6, 1 by 6. And then next which table? 2 table possible, 2 3s are 6. And again 3 table, 3 2s are 6. And then which table? Then 4 table not possible, 5 table not possible, then 6 table, 6 ones are. After that anywhere you get 6 elements not possible. So possible order of matrix with 6 elements are these are 1 by 6, 2 by 3, 3 by 2, 6 by 1. These are the possible orders of a matrix with 6 elements. So this is about your problem number 4. And then now we are going to the another problems. Alright, let's move on to the 5th problem. Find a matrix A is equal to Ij of order 2 by 2, whose elements are Aij is equal to 2i minus j upon 3i plus j, and Aij is equal to I plus 2j whole square upon 2i, and third one Aij is equal to 2i minus 3j. This we need to understand how to solve. It is already said previously, just you need to substitute. And let me write first what is our order of 2 by 2 general matrix. So A 2 by 2 matrix is nothing but, if A is a given, A11, A12, A21, A22. So then it is 2 by 2 matrix. So now I need to find now A11, A12, A21, A22. So with first one what? Aij is equal to 2i minus j upon 3i plus j. So first A11, wherever I is there 1, j is also 1. 2 into 1 minus 1 upon 3 into 1 plus 1. That means 2 minus 1 is 1. 3 plus 1 is nothing but 4. Same method now A12. So A suffix 1 2 here. So 1 2 means 2 into 1 minus 2 upon 3 into 1 plus 2. Anyhow 2 minus 2 is nothing but 0. 0 upon any number whatever it is 0. So next one A21. So now 2 into 2 minus 1, 3 into 2 plus 1. 2 2s are 4, 4 minus 1 is nothing but 3 upon 2 3s are 6, 6 plus 1, 7, 3 upon 7. So next A22. So now 2 into 2 minus 2 upon 3 into 2 minus plus 2. So now here 4 minus 2 is nothing but 2. And then 6 plus 2 is nothing but 8. 2 1 2s are 2 1s are 2, 2 4s are 8. So you get 1 upon 4. So what is about your matrix now? Therefore, matrix A is equal to, what about your 4 elements? First 1 upon 4. Second one is 0. Third one it is 3 upon 7. And our fourth one is 1 upon 4. So it is 3 upon 7. So this is about your capital A, and A you got as 1 upon 4, 0, right, A you got as 1 upon 4, 0, 3 upon 7, 1 upon 4. So that is about your first one, and let's move on to our second one. What about your second one here? So second one, Aij is equal to I plus 2j whole square upon 2i. So directly I am substituting here now. So first A11. So this is about your second one. A11. So 1 plus 2 into 1 whole square upon 2 into 1. So 2 1s are 2, 2 plus 1, 3. 3 square is nothing but 9 upon 2. So first one it is 9 upon 2. Then same method A12. 1 plus 2 into 2 whole square upon 2 into I. I is nothing but again 1. So now 2 2s are 4. 4 plus 1, 5. 5 whole square is nothing but 25. So that is 25 upon 2. So now you got as 2 elements, and let's move on to the third element here. The third element is A21. So A21 means what you get, 2 into 2, sorry, here only I. So I is nothing but here 2. 2 plus 2 into 1 whole square upon 2 into I. 2 into I is nothing but here 2. So now here 2 1s are 2, 2 plus 2 4, 4 whole square is nothing but 16 upon 2 2s are 4, 4 1s are 4, 4s are 16. So you get as 4. And now A22. So if you want A22, what we can do, let me write this down itself so that you get, okay, no problem. So A22 is nothing but, so first I is 2 plus, next 2 into j, that is 2 into 2 whole square upon 2 into 2. So now we can write again here 2 2s are 4, 4 plus 2 6 whole square, that is nothing but 36. And then 2 2s are 4. Now in 4 table 36, when you get 4 9s are, so 4 1s, 4 9s. At last your required matrix capital A is equal to, what is first one, 9 upon 2, 25 upon 2, 9 upon 2, 25 upon 2. Next 4 and 9. So this is about your second one, and next third one as homework, you have to complete that third one like this manner, just substitute by your own. So that is about your fifth problem. Let's move on to the sixth problem. Alright, let's move on to the problem number 6. Find a matrix A is equal to A of order 2 by 3. Whose elements are A is equal to half 2I minus 3j. Again same method, substitutions only. You just need to substitute, but here now 2 by 3. Columns will be how many? 3, and rows will be how many? 2. So then that is also, let me solve. Now first let me write the order A 2 by 3. means 2 rows, 3 columns. So now again here A11, A12, A13, A21, A22, A23. So first we need to write this general form. So after writing general form, just find now normal method. So A11 half 2 into 1 minus 3 into 1. So now we can write here half modulus 2 minus 3. 2 minus 3 means minus 1. In modulus minus 1 is there, we can write it as plus 1. 1 into 1, 1 upon 2. So A11 is 1 upon 2. Then next one A12. So half 2 into 1, 3 into j is nothing but here 2. So modulus closed. 2 3s are 6 and here 2 1s are 2. So minus 6 plus 2 is nothing but minus 4. So modulus of minus 4 is nothing but plus 4. So then we can write here it as plus 4 upon 2. 4 upon 2 is nothing but 2. So that is about A12. Next one it is A13. Half 2 into 1 minus 3 into, that is j is nothing but here 3, write that 3. So that 9 minus 2 is nothing but you get as minus 7. Right? So minus 7 becomes as plus 7. So I'll write half modulus of minus 7. So that is nothing but 7 upon 2. So A11, A12, A13 completed. Now next one A21. So half modulus 2 into 2 minus 3 into 1. So now 2 2s are 4, 4 minus 3 is nothing but 1, plus 1 is there means only plus 1 will write. So that is nothing but 1 upon 2. So you got A21 is equal to half. Now we need to go for A22. So now I'll write here that A22 is equal to half modulus 2 into 2, 3 into 2. So 2 into 2 minus 3 into 2. That is nothing but 3 2s are 6, 2 2s are 4. 4 minus 6 is nothing but minus 2. So now you get here it is minus 2 modulus into half, that is nothing but 2 by 2, that is nothing but 1. And now here A23 half modulus 2 into 2 minus 3 into 3. So 3 3s are 9, 2 2s are 4. So minus 9 plus 4 is nothing but minus 5. So now you can write here it is half modulus of minus 5. That is nothing but 5 upon 2. Now at last you can write therefore capital A is equal to, what is your A11 is nothing but half. A12 is nothing but 2. A13 is nothing but 7 upon 2. Then next A21 is nothing but again half. Then A22 is nothing but 1. A23 is nothing but 5 upon 2. So this is about your matrix A. So you got answer as half 2, 7 upon 2, half 1, 5 upon 2. This is about your problem number 6. I hope so you are not got any doubts, because just in the I place whichever one is there, one substitute, j place one is there means when you have to substitute. Just substitutions you have to do and you will get your answers. This is about your problem number 6. Let's move on to the problem number 7. 7 only here itself it is there 7, so that it becomes easy for you. So I'll write here itself. Now this 6th one not at all required for you. Just a 7th problem. Okay. So they given for you in this 7th problem, if A plus B 2 and these all equal they given, means these two matrices are equal, then find the values of A and B they given. So if both are equal, first you need to compare corresponding elements. A plus B is equal to 6 and AB is equal to what you get? You get as 8. So now you can write here comparing corresponding elements. First one you need to write comparing corresponding elements. A plus B is equal to 6 Another one it is AB is equal to 8. So from this, what is you have formula? A minus B whole square is equal to A plus B whole square minus 4AB. This is formula. Apply this formula. Then A minus B whole square is equal to A plus B whole square is nothing but 6 square minus 4 into AB is nothing but 8. So 6 square is 36 minus 4 8s are 32. So you write that, and then A minus B whole square. So A minus B whole square is equal to, you can write 36 minus 32 is nothing but 4. So now A minus B whole square means what you are going to get. So now A minus B is equal to square root of 4. That means A minus B is equal to plus or minus 2. So means here A minus B plus 2 you can take, A minus B minus 2 you need to take. So now how to solve it is, first you know that A plus B is equal to 6 and A minus B is equal to, first I will take plus 2. And same method, another one, A plus B is equal to 6, A minus B is equal to, now minus 2 I will take. So first plus 2 take, then minus 2 take and solve it. So here first add both, here also add this and this, minus B plus B get cancelled. 2A is equal to 8 here. Here 2A is equal to 4 and A is equal to 2 1s, 2 4s. So that 4 you get 2 1s, 2 2s. A is equal to here 2. When A is equal to 4, what is your answer? So A is equal to 4, substitute in this place. 4 minus B is equal to 2. Minus B go to that side, plus B, plus 2 comes to here minus 2. 4 minus 2 is equal to B, B is equal to 2. And here A is equal to 2, substitute 2 minus B is equal to minus 2. Minus 2 comes to here plus 2. 2 plus 2 is equal to minus B, go to that side, plus B, B is equal to 4. So at last A is equal to 4 comma 2 and B is equal to 2 comma 4. This is your values. So that is about your problem number 7. So I hope so you all understood, and let's move on to the another problem, that is problem number 8 and 9, remaining 2 problems. These are the last 2 problems of exercise number 3.1. okay, let's move on to the 8th and 9th. Alright, first we are going to discuss this 8th problem, that is if if these two matrices are equal, find the values of x, y, z and p. So if they given equal to, simple compare corresponding elements only. So solution, comparing corresponding elements. You need to write again this separately, then only you have to solve. Okay. So now first one with first, that is what, 2x is equal to 4, then 2 1s are 2 2s are, x is equal to what you get, 2. So x value you got. Now just substitute next one. What is the next second element with the second one? What is that? 3x plus y is equal to 5. 3 into what is x you got, 2. Just substitute, plus y is equal to 5. 3 2s are 6 and plus y comes to, anyhow 6 plus y is equal to 5. Plus 6, go to that side, minus 6. Y is equal to 5 minus 6. Y is equal to minus 1. Now x value you know, y value you know. Anyhow, now its third element you can compare. Minus x plus z is equal to minus 4. Now, minus, what is x here? 2. Plus z is equal to minus 4. Minus 2, go to that side, plus 2. So z is equal to minus 4 plus 2. Z is equal to minus 4 plus 2 is nothing but minus 2. So you got x value, y value and z value. Now we are going to find p value. So what is next one here? It is 3y minus 2p is equal to minus 3. Next one, comparing corresponding element, last one. So 3 into what is your y? Minus 1 minus 2p is equal to minus 3. Minus 3 minus 2p is equal to minus 3. Minus 3 comes here, plus 3. So minus 3 plus 3 is equal to here, minus 2p. Go to that side, what will happen? It is plus 2p. So 0 is equal to 2p, and multiplying comes to a division, 0 upon any number you get as 0. So p value is 0. So at last you can write therefore x is equal to 2, y is equal to minus 1, and z is equal to minus 2, and p is equal to 0. So this is about your problem number 8. So I hope you all understood this. X is equal to 2, y is equal to minus 1, z is equal to minus 2, p is equal to 0. You got. Like this you have to solve when they given equal, and these kind of questions you may expect for 2 mark. And in this matrix, the chapter number 3 you are going to get as only 3 marks. And then another chapter determined also 3 mark, and last one it is going to be the 4. Totally 10 marks you are going to get from this whole matrices chapters. Okay, so that is about your chapter number 3, exercise number 3.1 8th problem. So now let's move on to the problem number 9. Let's discuss last and final problem. For what values of ABC matrices A and B are equal matrices, where A is equal to, and then this is B equal to they given, and these both are equal. So our solution, so given here A is equal to B. So I'm writing, you need to write again these two matrices separately, and then you have to compare. Okay, so I'm directly comparing here. So now first one here, when you compare second element with second, then C is equal to what you get, 3. And then A value I want to, for B value also I want to find now. So what we need to do, where is the easiest one here? It is, okay, C is equal to 3 you got. And next B plus 2 is equal to A minus 2 is equal to B. So now I can write here A minus 2 is equal to B. Another one, it is B plus 2 is equal to A. Not required this. I hope so. Easiest method is there for you for this. So it is directly, what you need to do is compare these two elements. 12C is equal to 6B. By using that you find your B value. 12 into C is nothing but 3, that is equal to 6B. 3 1s, 3 2s. Again now 2 1s are 2 6s are. So now directly what we can write in this place, B is equal to 6. So B value got as 6. And then C value got as 3, and then it is very easy now. Now first one, A minus 2 is equal to B. Now A minus 2 is equal to B is 6. A is equal to minus 2, go to that side, plus 2, 6 plus 2. So A is equal to 8. Here observe carefully, easiest method I was observed. So the first it is, you found here C and 3, so that C is equal to 3. So once C value got, the B value if you want to find, that is with the relation with the C required. That's what 12C is equal to 6B I took. And now C place just substitute 3. And then now with the cancellation, if you do B is equal to 6 you get. Then now A and B relation. So A minus 2 is equal to B is there. So the B is 6, substitute, you get A value as 8. So therefore, what is A? A is equal to 8. B is equal to 6, C is equal to 3. For these values, these two matrices should be equal. That is about your problem number 9. And now if you have any doubts, kindly comment on the YouTube section, so comment section, so that I can help you all. So may God bless you all.